Hello and welcome again to the deep learning course. Today we'll be working with the transformation of the image. It will be just a pre-processing step that you can use inside your dataset module, for example, in the get item method, or you can also run it through the reading of the image. You can also use it in the same way. So let's get started and check some of the pre-processing transformations. So I have imported this fashion MNIST dataset instead of the original MNIST. It's just another version of the MNIST and with different images, but the same number and the same dimensions. Transform here is the one that we are going to focus on through this tutorial. It is imported also from TorchVision because it's an image pre-processing step. So let's get started. I have here downloaded already this data and let's check its shape. As you can see here, it is 60K by 28 by 28. And let's plot some of these images. For example, here I'll be plotting 10 images, and that first dimension will be, and here I'll be making it black and blue. So for example, here I have read this dataset now and plotting such a batch of these images, and I need to apply some transformation across such image. Okay, so transformation actually is using this transforms.compose function, which is takes a list of transformation pipeline, and it is applied in sequential way to the image. So I have, for example, here transforms dot. All of these are a transformation part. Like I can center crop, I can crop part in the center of the image. Grayscale is to make it the image into a single channel image, which is already a single channel, so we don't need to use it. For example, I have a normalized one, which is pretty much good one. Like normalization is efficient for making our images in such a way a uniform distribution, like the distribution of the images is the same somehow. So while learning the model of the convolutional model, it will be easier in learning. Okay, so we will be using it, for example, but I first let's start with some simple transformation like the resize one, and it takes a size as input in a tuple format. For example, I need here to make it for example 10 by 10, and let's save it in a tr object. And here I will be reading a single image. For example, here from the MNIST data, I'd be picking any image, and important thing is it needs to be in a 3 dimension. So currently the image is in 2 dimension, so we need to convert it into a 3 dimension. Let's add one as a new axis and 28 by 28. Okay, so now let's apply this transformation of the image. It's just like this. It takes this transformation in such a way, and here let's call it the image transformed. As you can see, it is now transformed, and I can check its shape. It is 1 by 10 by 10. Okay, and I have also can apply another thing, which is the random. And you can see here a multiple random methods can be applied. Like for example, a random horizontal flip. It doesn't take anything. I can then apply this horizontal flip. It needs to be, for example, here I need to show this image transformed, and this facet color will be 0. Okay, I think it will not be shown through this image because it's a little bit uniform. Okay, so for example here I can apply this transformation again, And as you can see, it is being horizontally flipped, and the vertical flip also can be applied through this method. Like I have this vertical flip, so it will be applying it in the same way, in that way. So this is just called a data augmentation. So I'm learning the model that if you can see this image in any format, and this also should be suitable with this with the use case. Okay, so for example, if I need to make the model understand how the shoes is being weared, so I don't need to the vertical flip. Okay, I just need to, maybe the horizontal flip will be good because the shoes can have 2 feet, okay, in the opposite direction. So the horizontal flip can be fine with this if I have the data with bias to a single direction. So I can also apply this horizontal flip to make the model learn different features of the data, and to make it already seen, like if the test data contains some other distributions or other views or perspective of the data. I can also here apply some, for example, um, let's see the normalization. It can be also random rotation can be applied, and this is a number of degrees, how many degrees you need. For example, I need 30 degree of rotation. So as you can see here, this can be also very helpful if we have a pretty much deep use case with many images or small images. You can also apply this pre-processing in order to increase the number of images you have already in your uh, data, and to make the model learn more features of our data. Okay, I can also use the normalization part. For example, here I can use this normalize, and normalize takes the mean and the standard deviation. Normalization is, as we have discussed before, it is a pretty much important thing that we need to compute the mean and the standard deviation of our rule data and give it these parameters in order to uh, stabilize or apply uniformity to the images. Okay, so for example, here I need to make it the float and calculate the mean, dividing it by 255. So it is 0.28. Let's check the scalar value of it. This is for the mean, and also we need to apply the same or different thing for the standard deviation, mean and standard deviation. Okay, so these parameters can be now imported to the normalized part. It will not be as much seen, or for example, it will not be noticed from our side. Okay, as you can see here, input tensor should be a float tensor. Good torch you int. It is a data type within the image dataset itself, so you need to change from the image here to be a float, because the normalize accepts only float tensors. And run it again, and here for example it have already normalized or applied this, it subtracts the mean from all the pixels and also divided each pixel by the standard deviation. So basically all the images will be the same distribution. Okay, for example, also it can be having I can have the random crop. I can crop the image in random areas, and it also takes a tuple because it's a size. For example, here I have a random crop of 10 by 10. Okay. So as you can see here, it focused on a single part of the image. This also can be useful for some use cases if you need to have many objects and you need to make it focus on some objects of the data. Okay, you can play also with different types, and finally where to insert this transformation in our 6 modules that we have already discussed through our first lectures. Basically you can make it within the data module that we built. For example, this class dataset okay, that we have init three functions, if you remember, the init and the get item, and also the final one is the yeah, this get item. We can here apply the any pre-processing transformation. Okay, we can apply this to the image because it basically sends the index of the image. So I can here use applying the transformation across this image. Or also, if I have the images in a directory, okay, I can read these images from the directory by the data loader, because data loader will be fetching a batch of images from the directory, from the disk to the RAM in a sequential way. And the data loader also can take this image folder. It is from the TorchVision, from the Torch dataset, from the TorchVision dataset. I can import this image folder. It takes the root of the directory. So, for example, here I have dogs of. I don't try to explicitly define this PNG, only defining this root directory. Okay. So, for example, here I have the path to images, and I just leave it like this, and it will be reading all it have access to all these images. And here is the transform part. I can just pass it to this parameter as an argument, and here I can put it inside a data loader where it will be loading such dataset in batch, and the batch size, for example, so it will be loading each 32 image and applying the transformation while loading, and then inserting them to the model. And in that case, I don't need to add it through the dataset. Okay, hope you understand this lecture in a good way. And you can also play with other transformations and using other datasets. You can try from the TorchVision library. Hope you enjoyed this lecture, and see you next time. Thank you.